Alrighty, we got the notes for section 8.3, which is with hyperbolas. Hyperbolas are kind of like inside-out ellipses. Instead of the focuses being in between the center and the vertex, they're on the outside, which means it looks like you have two parabolas that open away from each other. So the hyperbola is the set of all points in a plane whose distances from two fixed points in the plane have a constant difference. The fixed points are the foci of the hyperbola. The line through them is the focal axis. The point on the focal axis midway between the foci is the center, also midway between the vertices. Points where the hyperbola intersects its focal axis are the vertices, blah, blah, blah. So what that's saying is that any point I measure, like, whoops, that, here's D1, here's D2, the difference is some common value. And it doesn't actually matter which parabola I go to, D2, D1. Notice you have the absolute values. That makes it always be positive. You're talking about the distance, so it doesn't matter whether it's a positive or negative number. Okay, so here's our stuff for the hyperbola. So if you notice, this one you cannot reverse the order because subtraction order matters. So x squared over a squared, y squared over b squared. So this one will move in the x direction. If you put y first, it is vertical, so it doesn't actually matter which one's larger, a or b. For an ellipse, a is always the bigger, b is always the smaller. In a hyperbola, a is always the first, b is always the second. So if x comes first, the x-axis runs horizontally, which means the parabola is open left and right. If the y is first, the parabola is open up and down. So your foci are c away from the center, your vertices are a away from the center, just like before. Semi-transverse axis, so transverse means connecting the two vertices. So remember, the full length is a, so the transverse axis length is a, semi means half of that. Semi-conjugate, that's going up and down, would be b. Here's your Pythagorean relationship, so this looks more like the Pythagorean theorem, a squared plus b squared equals c squared. And you have these two lines referred to as the asymptotes, which are lines that the graph will approach but will never cross. Now, what happens is if you're trying to sketch an hyperbola, you actually draw a rectangle first. This distance is 2a, this distance is 2b. So we'll make this one open left to right. The asymptotes pass corner to corner. And when you draw your curves, they will approach that asymptote, but will never cross. And they touch the box, because remember that's the a distance, so that's where the vertices lie. So that would be how you'd actually sketch an ellipse. Oh, sorry, not ellipse, hyperbola. Okay, example 1. Find the vertices and the foci of this hyperbola. Well, just like with ellipses, they're equal to 1. So x squared over 9 minus y squared over 6 equals 1. So since x is first, regardless, this hyperbola is opening left and right, which means this value here is a squared. And this value here is, that's not 6. What am I doing? That's 4. That's b squared. So c squared equals a squared plus b squared, which is going to be 9 plus 4. So c squared is equal to 13. So a is 3, b is 2, c is root 13. So the vertices are at plus or minus 3, 0. The foci are at plus or minus root 13, 0. I know I have to add it to the x's because x is first. If this terms have been reversed, if the y was first, these numbers would be added to the y's. So, okay. Yep. All right, so 2, find an equation of hyperbola with given foci whose conjugate axis has length 4. So this conjugate axis is the short distance, so this distance is 2b, which means that b is equal to 2. Sketch the hyperbola and its asymptotes, and support your sketch with a grapher. Okay, so these numbers are c, so c is 3. C squared is equal to a squared plus b squared, so 9 is equal to a squared plus 4, so a squared is 5, so a is root 5. So since my y values are changing, this hyperbola opens up and down. So the y has to come first. So y squared over a squared, which is just going to be 5, minus x squared over b squared, which is going to be 4, equals 1. Now, if I was going to try to sketch this honestly, root 5 is about 2.2. So I'd come out about 2.2 in the y direction, up and down. Square root of that, so I'd go over 2. So here and here. And I would use these points as midpoints of a rectangle. Its asymptotes will pass corner to corner. And since the y is first, this has to open up. It's going to touch the box there where I make my point. So that would be the sketch. Yeah? Yeah. Okay. Just like with ellipses, you can move them around just as the HK term, but it's mostly the same. The only equation the asymptotes get super fun, but these are the generic equations. There's 2 of them, which is why there's a plus minus out front. All right, so example 3, find the standard form of the equation with a hyperbola whose transverse axis has endpoints blank and blank, and whose conjugate axis has length 8. So this value here is 2b, which means that b is equal to 4. The transverse axis is the long direction, so this is 10 units long, so 2a is equal to 10, so a is equal to 5. So this is actually a similar setup to one in the previous section. We're just using a hyperbola. Okay, so I need to find c. Actually, I don't. This hyperbola is opening left and right, so x comes first. So x, I need to find the center. So just like before, it's going to be halfway between this. So take 5 and come backwards. Either subtract 5 from this or add 5 to this. So it's going to be centered at 3 comma negative 1. So x minus 3 squared over a squared minus y minus k squared over b squared equals 1. And that's it. So once you have h and k and a and b, you don't actually need the value of c if all you need to do is write the equation. Okay, find the center for vertices and foci. So the center lies at hk. So let's list our variables over here. So h is negative 2, k is positive 5, a is 7. No, it's not, because these are a and b. For hyperbola, a is always first. So a is 3, b is 7. So to find c squared equals a squared plus b squared. So c squared is root 58, which I don't know if you can simplify that at all. 58 divided by 4? Nope. So this is just c is equal to root 58. So I don't think any perfect squares go into 58. So the center lies at hk, negative 2 comma 5. This one opens left right because x is first, which means everything's going to be added to the x value. The vertices, there'll be 2 of them. It'll be h plus a and h minus a. So negative 5 comma 5 and 1 comma 5. So take this value, subtract 3 to get the one on the left, take this value, add 3 to get the one on the right. Foci are going to be h plus or minus root 58, because it doesn't simplify, comma 5. So there's your parts. Just like with ellipses, hyperbolas have eccentricity, similar formula, except this plus in the middle here, where is the a is the semi-transverse axis, so half of the essentially major axis, semi-conjugate axis, the short distance, and c is the distance from the center to either focus. So this one's a little bit easier to use, this version, because it doesn't involve that d value, but works either way. This way, you could do it straight from the formula without having to calculate c first. Okay, so example 5. Comet following a hyperbolic path around the sun has a perihelion distance of 90 gigameters. When the line from the comet to the sun is perpendicular to the focal axis of the orbit, the comet is blah, 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 blah from the sun. Calculate A, B, C, and E. What are the coordinates of the center? If we coordinate the space, the hyperbola is given by this equation. Okay, so we need to practice draw a lovely picture. So let's see here. So the closest approach is going to be C minus A. So that's the perihelion distance. So I know that C minus A is equal to 90. Let's see here. What else do I know? Now this number here gives me the value for B, perpendicular to the focal axis. The line from the comet to the sun is perpendicular to the focal axis. Right. So that's the value for B, I'm pretty sure. Let me make sure here. No, that's not B. I gotta think about this for a minute. Perihelion distance is that, right? An axis. Okay, so an x is equal to C. So I know that this is true. B squared equals C squared minus A squared. That's true. Now, when x is equal to C, y is equal to plus or minus B squared over A. Essentially, it's the, what am I looking for? Asymptotes without the x. So let's see here. So B squared over A is equal to 281.25. That's that number. Let's see here. Or if I solve that, B squared is equal to 281.25 times A. All right. So what else do I know? So I know that C minus A equals 90. I know that C squared minus A squared equals B squared, which I just figured out what it is. So this is just rearranging the Pythagorean, 281.25 A. So let's see here. So I can rearrange this. So C is equal to A plus 90, which means this becomes A plus 90 squared minus A squared equals 281.25A. You can expand that. So that's A squared plus 8100A minus, plus, no, 180A plus 8100 minus A squared equals 281.25A. So those A squareds cancel. So moving all the A's over, I get 8100 equals 101.25A. Subtract the 180 across. And then doing some division, A, after all of that, is 80. If A is 80 and C minus A is 90, that means C is 170. Oops. And then I can do, let's see here, B, C squared equals A squared plus B squared, so 170 squared minus 80 squared, take the square root of that number, so B is 150. So let's see here, I can plug all the numbers in. So calculate, there's A, B, and C, and E, so the eccentricity is given by C over A, which is 170 over 80, which is 17 over 8, or about 2.125. So there you go. all the fun numbers. That is the end of the section.